Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the third question from the Saheti school preliminary exam, which was written in the year of 2023. Please do expect a total number of 11 videos since the question paper had 11 questions in total. That simply means each and every question will have its own video. And please guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your preliminary exam and most importantly your final examination. So please do share the video to your peers so that they may have the same edge as you, and please guys do help us grow the channel by just subscribing. Okay, I'm supposed to consider the function of p of x. I'm being asked whether is p an increasing function or a decreasing function. P is a decreasing function, guys, ne? Why? Because the coefficient of x is negative. Or you can simply say because as x increases, the value of y keeps on decreasing. You can even check that, guys, ne? Just keep on increasing x, you'll see that the value of y will keep on decreasing. That's why p is a decreasing function. Then now I'm supposed to draw a neat sketch of p of x and clearly show the asymptotes and the x-intercepts. Okay, the asymptotes and the x-intercepts. Since p of x, guys, is a logarithmic function, I'll simply have a vertical asymptote. And my vertical asymptote is that x is equal to 2. Just take the index 2 minus x, make it to be equal to 0, and then solve for x. You'll find that x equal to 2 is your asymptote. Are you together? But remember that, guys, we are dealing with the decreasing function over here. With the decreasing function, as x increases, the value of y keeps on decreasing. Okay, and then the y-intercept over there, guys, just substitute 0 whenever you come across x. You will simply find 1 as your x value, and then the y-intercept is 1 rather, and then for the x-intercept is also 1. Let me just show you how I got those. I have y, 0, x-axis. For my y-intercept, I simply said I don't care what kind of a graph it is, I'll always make x to be equal to 0. And therefore, that's why being equal to the log of 2 minus 0 base 2, this will just give me 1. And then for my x-intercept, make y 0 always the time, and then solve x. Y will be 0, and then I'll have log 2 multiplied by x base 2. I can remove the log by simply taking the 2 to the other side. I'll have 2 to the power of 0 is equal to 2 minus x. And then I'll end up having 1 is equal to 2 minus x. And therefore x is just 2 minus 1, which is just equal to 2. Equal to 1 rather. So that's how, guys, I found my x and y axes. Okay, and then I'm supposed to write down the range of p of x minus 1. Okay, first I must find the inverse before I translate it 5 units down. How can I find my, it's 1 mark, it's supposed to be easy. Okay, if ever, guys, if ever I'm translating my inverse 5 units down, that means I must also translate the original graph 5 units to the left as well. Are you together? If ever I do that, the new graph will simply be like this. The new graph will be like this. I'll have y, 0, and x-axis. If I'm translating the graph, guys, 5 units to the left, the asymptotes will be over here when x is equal to negative 3. And then the domain of my graph, I'll simply say the domain that's x less than negative 3. But remember that, guys, the domain is always equal to the range of your inverse. Therefore, the range, just know that y is just less than a negative 3. But you can prove that, guys, by simply finding the inverse and then translating the inverse 5 units down. Né? This is the final answer, by the way. Né? But if you're not sure about it, please find the inverse first. Né? P of x is given to us as the log of 2 minus x base 2. For my inverse, I must just reflect it on the line y is equal to x. That means I must just interchange both x and y. Are you together? I must just interchange both x and y. Okay. And then I'll end up having 2 to the power x being equal to 2 minus y. And therefore y is just equal to negative 2 to the power x plus 2. If I have to translate this thing, guys, 5 units down, therefore the inverse p of x minus 5 will simply be negative 2 to the power x plus 2 minus 5, and hence 2 to the negative x minus 3. Remember that, guys, your graph, since I have a negative value over there, that means my graph will be below the asymptote. The exponential graph will be below the asymptote. And since the graph will be below the asymptotes, that's why the range will simply be y is less than negative 3. You could have done this just for 1 mark, or just translate your original graph to the left and then find the domain of your graph. Just know that the domain of your graph will be equal to the range of your inverse graph. Okay, and then now I'm given f of x. I'm supposed to write down the domain and the range of f of x. For my domain, I know that x is an element of real numbers, but x cannot be equal to 1. For the range, y is an element of real numbers, but y cannot be equal to 2. Are you together? That's my range and domain. Okay, and therefore for me to sketch my graph, I'll just label the x and y axes and also write down the value of my asymptotes. Né? That's the vertical asymptote and that's the horizontal asymptote. X is 1 over there and then y is 2. The value of a is positive. That simply means my graph is in the first and third quadrant of my asymptote. So the first curve will be over there, then the other one will be like that, or it will just simply move like that. Né? If we can find the y-intercept, we will know where it moves. Our y-intercept will be negative. Yes, we can find it. That's just negative 2, and then the corresponding the x-intercept has to be negative as well. Né? How can I find my y-intercept? Okay, let's go and find y-intercept. Y-intercept, always make x 0, then solve for y. I'll simply say f of 0 is equal to 4. Whenever I come across x, I'm substituting 0. That's 0 minus 1 plus 2. Then the answer is just negative 2. That's why the y-intercept is negative 2. For my x-intercept, I know y is equal to 0. I'll simply say 0 is equal to 4 over x minus 1 plus 2. I can take the 2 to the other side. It will be negative 2 being equal to 4 times x minus 1. I can multiply both sides by x minus 1. I'll end up having negative 2 times x minus 1 is equal to 4. Divide both sides by a negative 2. Then x minus 1 is equal to negative 2. And hence x minus x is just equal to negative 1. So the x-intercept is just negative 1. That's how, guys, you're supposed to draw your graph. Then I'm supposed to use the graph to determine the values of x excuse me, for which this statement is true. 4 over x minus 1 being greater or equal to negative 2 can be written as 4 over x minus 1 plus 2 is greater or equals to 0. That's greater or equals to 0. Are you together? But this is just equal to f of x. So I'm looking for the values of x whereby f of x is greater than 0. From the right hand side of my asymptote, I can see that the graph will forever be above the x-axis, and from the left hand side of my x-intercept, the graph will forever be above my x-axis. So the answer, let me write them in blue. Therefore, x is just less or equal to negative 1, or x is greater than 2. I cannot include, not 2 guys, ne? 1. The x value over there is 1, ne? I cannot include the 1 because x is equal to 1 is an asymptote. That means the graph is not defined whenever x is equal to 1. That's why x is just greater than 1. Now I'm supposed to determine the equation of the axis of symmetry of f of x minus 2 that has a negative gradient. Okay, f of x minus 2 will simply be equal to 4 all over x minus 2 minus 1 plus 2, and this is just equal to 4 over x minus 3 plus 2. Okay, so the coordinates whereby the axis of symmetry touches our graph, or rather divide our graph into 2 halves. The point is just 3 and 2. Are you together? The gradient of a line is negative 1. So therefore, the equation is just y is equal to negative x plus c. I just need to find the values of c. The y value is 2 if the corresponding x value is x. So therefore c is just equal to 5. Therefore the equation of the axis of symmetry, that's negative x plus 5. That's how, guys, you're supposed to deal with the third question over there. So please, guys, do stay tuned and wait for more videos. Thank you very much.